Hey, it's me, Tethered, the masterful redstone engineer. Did some philanthropy. Sucked. I took a blinker and now I'm here. Today I'm going to be showing you how to make a redstone copper bulb cell in Minecraft. As I know, this is the first design. It's going to get copied 5 billion times, probably made better. But this should probably be good enough for your builds. It was good enough for this computer, and it should be good enough for you, you ungrateful person. Anyways, the way this works is it's on the basis of this new T flip-flop, 2x1 T flip-flop. Great. You can modify this, so see, look, now it's locked. You can't do that. AND gates are really cool. So right here, I have a slice out of the just one. The great thing about this and why you should probably use it is look at these memory cells. They're right next to each other. You can use above above memory cell lines to make this work. So great stuff. Let's start on it right now. Time set day. Sorry for coughing. As I said, I took a blinker before this. I'm making this for you. I hope you enjoy. Start this off. You have your 4 lines, 4 bits. You can stack this for 6 bits. That's 6-bit right here. You can stack this as many bits as you want. You're just gonna run into different problems along the way, like having to use like spacing, and maybe you're trying to make a perfectly timed computer. So yeah. Just figure it out for yourself. Everything's gonna work for each other. So yeah, we're gonna have this copper bulb going into a comparator. That's the T flip-flop that we all know that I just showed over there. Get that power out. Sorry. more coughs for the crowd. Anyways, bring this out. Have your redstone torches. We're inverting this and then uninverting it, and that's good because then we can use an AND gate to make sure that nothing gets out of there unless we want it to, as in the signal. But yes, this is the reset line. This is also what locks the mechanism. I guess this is another AND gate, or yeah, another AND gate, but it's just all AND gates. If you don't know anything about this, it's just all AND gates. I'm gonna stop explaining the gates because it doesn't really matter. We got reset line right here all the way across. I don't know why I spaced that out. These need to be connected. So the reset line does need to be powered. It makes it look dense right here, but whenever you're doing it in a full system, you'll usually invert the power a few times, so inevitably you just design it to be inverted. But yes, right now we have the full thing, so put in 1, we can get rid of the 1. We can also set this. So that's the right line, or sorry, that's the reset line. Right now we're gonna write the read line. So right here. So what this does is, since these torches are always on, you can't read out because no matter what, it's just going to be on. Like, I don't know how to explain it other than that. But yes, now we have right. No, we don't have the right yet. We have reset, we have read, and now this is the whole memory cell you might need. This can perform anything you want, store memory. But the problem is, if you can't, like, if you say something else comes through here, you're just going to come hit that one and you don't want to. You need a right line. But right now, this is the whole cell. A little thing about it, if it's powered, when it's resetting, it's going to still save that thing, which can be used really good, but it's also kind of annoying depending on the design you want. So that's why we're going to finally now make the right line. So the right line, we're going to do another inversion, just so we can have another AND gate for the lines, if you can see a pattern of how these lines work. But you would have this going out, like this would be coming in from something like this, so you'd be like doing this typically for just bringing it in from a bus, but might not be using it for that reason, so I'm going to keep on doing this. Sorry if I'm trying to push redstone computing on you and you're not even looking for that. It's just a very good day. Right here. Bring this over. And we have our 4 lines like this. Very simple. So now we have one more line we need, and this is the right line. So just power these. Go ahead and put some buttons back here so we can do some stuff. And it is done. This is the whole memory cell. This is going to be spread out differently inside of your build, but this is the whole memory cell. I know it looks big, but as part of the system, this gets really small and compact if you engineer it right into the build. Because, here, I'll explain it one more time. See, like, it looks small right here because it's part of the build. Like, this inversion is going to happen whenever you're working with memory buses. So if you kind of build the memory inside of the other build, it will make it net smaller. I don't know if that makes sense to you, sorry. But here, let's do it. Let's do a reset. Let's put a button here. But yes, we got our whole memory cell working. So we can't write right now because we don't have the read line activated. You can invert this. So if you wanted it where it's just a NOT gate. If you want it the opposite, you can just invert it. But right now we only want to write whenever we have that on. So 1, just put in freaking, what is that? 10? Sorry, my binary's slow right now. But right here, read, so we're reading 10 at the end. And now we turn off the write line. Even though this power is still coming in from those, we can just reset that. And it's done. I hope that explanation wasn't too long-winded. I hope it wasn't stupid. But always, this is Tettered, the master redstone engineer. Took some blinkers. Now I'm out of here. I didn't hit the right button.